What did one math book say to the other? Hey, don't bother me. I've got my own problems. Anyways, my opening joke there. This is 3-1C factoring expression. This is the last video for 3-1. Okay, your I can statement is I can factor expressions using the distributive property. Notice this word, this property keeps coming up, okay? So if you haven't quite understood it yet, now is the time to understand it. And obviously I made a typo here on agenda. Let's get rid of that N, my bad. Okay, so the agenda for today is to review the distributive property and then complete 3 example problems. Here we go. Remember, the distributive property looks something like this. If we plug in numbers, I'll kind of start right here. It makes a little more sense. We move the 2 and multiply it by the 5, and we multiply the 3 by the 2 as well. We distribute that 2 to both numbers inside the parentheses, and we get this statement of 16. And if we'd done it the other way and we combine the 5 and the 3 first, there's just 2 times 8, that got us 16. So it works. If we do it the distributive way or if we do it the old way, we still get the same answer. Well, factoring is just using the distributive property backwards. Okay, so instead of starting out with this on the left, we start out with this on the left, and we pull an A out. We look and say, hey, you know, there is a 2 being multiplied by both a 5 and a 3. Let's pull it out. Okay, and again, it works. You get 16 equals 16. This is difficult to kind of understand until we do some examples. So let's just do some examples really quick. Oh, and by the way, your number clue is it's divisible by 3. If you forgot what this word divisible means, you can ask me, ask a friend, or look it up. It's divisible by 3. Okay, factor the expression. So this is a lot easier than it looked like on that first slide. Remember, sometimes the easy stuff I make sound complicated because I'm trying to get you to understand the easy stuff at a deeper level. But now I'm going to explain it the easy way, okay? You simply look at your terms. Remember, this is a term and this is a term, okay? And you think, is there a common number that can be pulled out? Well, I see a 4. And this is what I mean. If I pull the 4 out and I wrote something like this, would what I wrote right here equal this up here? Well, it would, because 4 times x gives me 4x, and then 4 times 4 is 16. So what I did is I looked at the coefficient of this term, 4, and I looked at this number here, 16, and I noticed that 4 went into both of them. So I pulled 4 out. And that's what factoring or factoring the expression means. So if someone says factor the expression, they want you to find something that's in common to all the terms in the expression, the 4x and the 16, and pull it out. Okay, so this is the distributive property in reverse. Let's do another one. Okay, so here I'm looking for something that's in common. I see a -5 here and a -25 here. Well, right off the bat, I can tell that -5 goes into both. So if I pull -5 out, what would I have to multiply -5 by to get -5x? I'd have to multiply by x. But here's a tricky part. What would I need to multiply -5 by to get -25? A +5. See, many of us would be tempted to do this. We might write this instead. But unfortunately, what I just wrote here in circle does not equal what we started with. So if I distribute this -5 out to both terms, I get -5x plus 25. And that's not -5x minus 25. So be careful with what sign you end up putting in the parentheses, because whatever it is, you need to get the original thing when you factor. You're not changing the value of the expression. You're just writing it in a different way. That's what factoring means. Okay, one more. Right off the bat, I see that there's a 2 here and there's a 6 here. So I'm going to pull a 2 out of both terms. So 2 times x minus 3 should get me 2x minus 6, which is what I started with. So this would be my answer. Okay, it's that simple, and I think that's the last example. Yeah. So real quick recap, we're going to look for something that's in common, and here we have a in common, or in this case we had 2 in common, and we're going to pull it out. Now, and what's different about this example right here and the examples I showed you is back here, these were just all normal numbers. Where up here, we actually had some x's in there. But the same thing is true. Look for something you can pull out. All right, guys, I hope that was helpful. And I understand that this is new, so we're going to be doing some other stuff in class besides this video to help us fully understand this. All right, good luck.